Welcome to our lesson on linear equations in two variables. Sometimes we call them simultaneous equations because these are equations that are given two or more conditions, and for you to be able to solve them, you need to work them out considering all of them at the same time, and that is why we call them simultaneous equations. So at this level, we're going to look at three different methods that we use to solve linear equations in two variables. And the first method is the elimination method. Before we look at an example, we'll go through just a few steps that are required for us to be able to solve a system of equations or simultaneous equations by elimination method. The first method is to rewrite the equations so that the variables are properly arranged in order. Sometimes the equations can be written in such a way that the variables are not in order. They could appear on either side of the equal sign in the two or more equations that are given. So the first step or the first consideration is to rearrange the equations so that the variables are in order. For example, if you are given two equations that have the variables x and y, we rearrange them in such a way that in the first equation, if we are starting with the variable x followed by variable y and then the equal sign and the constant, we ensure that even in the second equation we start with the variable x followed by the variable y and then the equal sign and the constant. So that's what we mean by writing the equations in order. You should not solve the simultaneous equations if the variables are not in order, because that could be the beginning of confusions and you may not be able to find the correct answer. So once you have made sure that the equations are in order, or the variables in your equations are in order, then you need to decide, you need to choose which one of the two variables that you've been given you want to eliminate. Once you have decided, for example, if you have the two equations in x and y, you may decide to eliminate x first, which means you are going to solve and find the value of y in your equation. If you decide to eliminate the variable y first, it means you are going to solve and find the value of x. So once you have decided on which variable to eliminate, the next step is to check on what coefficients are on the variable that you want to eliminate. If the coefficients are different in the two equations, then you must make sure that you balance them. We're going to look at an example and just see how this balancing is done. If the equations have been given to you with coefficients that are already the same, which means the equations are balanced, the coefficients in the equations are balanced, then you can proceed to step number 4, which is to add or subtract the two equations so that you eliminate or you remove the variable you decided to remove. Once you've added or subtracted the two equations, you're going to remain with one variable. So you proceed to solve that one variable so that you know its value. Then once you have found the value of this one variable, you can now repeat the steps from step 2 to step 5 so that you solve for the other variable that you eliminated. So we're going to look at an example so that we see how to solve simultaneous equations by elimination method. There is a question which says solve the simultaneous equations 3x plus 2y is equal to 10 and 5x minus 2y is equal to 22. So we're going to follow these steps and solve the equations that we've been given by the elimination method. So our questions are 3x plus 2y equals 10. Three x plus 2y equals 10. Then 5x minus 2y equals 22. This is according to the example that we've been given here. So we're going to look at the steps that we just went through. The two equations that we've been given, we can call the first one, we can call it equation 1, and we can call this second statement as equation 2. So we can see that we are dealing with linear equations in two variables. Each of these two equations has the variable x and y. That's what we mean by linear equations in two variables, because each of the equations has two different variables, two different unknowns. Equation 2 also has the variables x and y. So we know that we have two linear equations in two variables. Now, we established that the first step is to make sure that the variables are in order. So here we know that in equation 1 we are starting with the variable x followed by the variable y and then the equal sign. In equation 2 also we have the variable x and the variable y, then the equal sign. So this means equations are already in order. So we are now going to proceed to decide or to choose which of the two variables to eliminate. So we're going to start with eliminating the variable x. That is our decision. So once we have decided that we want to eliminate the variable x, the next step we have said we need to check so that we balance the coefficients. So we can notice that in equation number 1, the variable x has a coefficient 3. In equation 2, the variable x has a coefficient 5. So in short, the coefficients are not the same. The coefficients are not balanced. So how do we balance the coefficients? We balance the coefficients by simply multiplying by the opposite coefficient. So what we do is in equation 1, the coefficient of x is 3. We are going to multiply this 3 by the whole of equation 2. So the coefficient 3, which is the coefficient of x in equation 1, we are going to multiply this across the entire equation 2. Then the coefficient 5, which is the coefficient of x in equation 2, we are going to multiply this coefficient across the entire equation 1. So the result of this multiplication, where we have swapped the coefficients, the result will be a balanced coefficient of the variable x in the two equations. We can proceed and do that and see how it turns out. So we are going to multiply 5 by the whole equation 1, which means 3x will multiply 5, it will give us 15x. Then 2y will multiply by 5, it will give us 10y. Then across the equal sign we have 10 times 5, which is 50. So this is the result of multiplying coefficient 5 across equation 1. Then we multiply coefficient 3 across equation 2, we're going to have 3 times 5x will be 15x. Then we have 3 times negative 2y, that would be negative 6y. Across the equal sign, 3 times 22, we'll have 66. So this is how we balance the coefficients. You can now notice that the coefficient of x in equation 1 is 15, and the coefficient of x in equation 2 is also 15. That means we have balanced the coefficients. The next step after balancing the coefficients is we have said we add or subtract the two equations so that we eliminate one variable. So when we add the two equations, it simply means we add the like terms. So we now look at equation 1 and equation 2 and add or subtract in this direction, where equation 1 and equation 2 will be dealt with in that order. So what do we need to consider for us to know whether we should add or we should subtract the two equations? We look at the signs of the coefficients of the variable we want to eliminate. That is our guide, because we want to get rid of one particular variable in the two equations. Our focus shifts to this variable and look at the signs of its coefficients in the two equations. So we see that in equation 1, the coefficient of x is positive 15. And in equation 2, the coefficient of x is another positive 15. So since we have positive 15 in equation 1 and positive 15 in equation 2, how do we eliminate a 15 and a 15 if you have two positive 15s? To eliminate simply means we want to make it become a 0, because when it becomes 0, it means it's no longer existing. So how do we make a 15 and a 15 become 0? We make a 15 and a 15 become 0 by subtracting them. When we say 15 minus 15, it will give us a 0, which means we have eliminated the variable x. So here we realize that because the two coefficients are both positive, we are going to subtract the two equations. We are going to subtract the two equations. And the case is also the same if the two coefficients were both negative. If the first 15 in equation 1 is negative and the second 15 is also negative, we were also going to subtract for us to be able to eliminate. So as a principle, if the coefficient of the variable you are eliminating has the same sign in the two equations, then you subtract the two equations. But if the coefficients have different signs, one is positive and the other one is negative, it doesn't matter which one is positive and which one is negative, whether the one in equation 1 or the one in equation 2, as long as their signs are not the same. If one is positive, the other one is negative, then you need to add the two equations to eliminate the variable. So in our case, in this example, the two coefficients are both positive, so we are subtracting the two equations. So we're going to say 15x in equation 1 minus 15x in equation 2, that is 0, which means we have eliminated the variable x, because 15x minus 15x is 0. Then we proceed to the next set of variables, which means we are now remaining with the variable y in equation 1, which has a coefficient of 10, and negative 6 in equation 2. So we're going to use the same operation, which is subtraction. We'll now say 10y, positive 10y minus negative 6y. Positive 10y minus negative 6y. So according to the addition and subtraction of terms and integers, we know that this minus outside the equations and the negative 6, they are multiplying to give us a plus, which means this is the same as 10y plus 6y, which will give us 16y. The result of the subtraction on the second term will give us 16y. Then across the equal sign, we have 50 minus 66, that will give us negative 16. So that is the result of the step where we are now subtracting the two equations. We have seen that we are now remaining with one variable y, and we have eliminated the variable x. So the next step, we said we can now proceed to solve for the remaining variable. So we are now going to solve for the remaining variable, which is y, and we solve for y by simply dividing by its coefficient. So we'll say we divide by 16 both sides so that we know the value of y. So when we divide by 16 both sides, we'll have y is equal to negative 1. So that means in the two equations where there is y, the value which is there is negative 1. We have solved for one variable. So according to step number 6, we are now supposed to repeat this procedure where we are now going to eliminate the variable y. Remember, we started by deciding to eliminate the variable x. So we are now going to start the same process by now considering to eliminate the variable y. So we'll write the equations again here. 3x plus 2y equals 10. Five x minus 2y equals 22. So we started by deciding to eliminate the variable x, and that process gave us the value y is equal to negative 1. So now in this particular step, we are going to eliminate the variable y. So after deciding that we should eliminate the variable y, the next step is to look at the coefficients. Are they the same or they are different? So we can see that in equation 1, the variable x is positive 2. In equation 2, the variable y has a coefficient negative 2. So in short, we have a 2 in equation 1 and a 2 in equation 2, which means the coefficients are already balanced. So there will be no need for us to swap the coefficients if these coefficients were not the same. For example, if there was 7 here in equation 1 and maybe 3 in equation 2, we are going to swap the way we did in the previous step, where we'll say 7 will multiply equation 2 and 3 will multiply equation 1. But since in equation 1 we have a coefficient 2 and in equation 2 we have a coefficient 2, even if the signs are different but the number is the same, which means the coefficients are already balanced. So we are going to proceed to decide whether we should add or subtract the two equations. So remember, we said if the coefficients have the same sign, then we should subtract the two equations. But if the coefficients have different signs, then we should add the two equations. So we notice that the coefficient 2 in equation 1 is positive, the coefficient 2 in equation 2 is negative, which means the signs are not the same, the signs are different. So what we are going to do is we are going to add the two equations. So if the signs of the coefficients are different, then we add the two equations. So as usual, we are going to effect the addition across the two equations as we did in the other step. Okay, we're going to do again equation 1 plus equation 2. So we have in this case 3x plus 5x, that will give us 8x. When we say positive 2y plus negative 2y, this plus and negative, they are multiplying to give us a negative, which means it's the same as saying 2y minus 2y. So 2y minus 2y will give us 0, which means we have eliminated the variable y. And here we'll have 10 plus 22. 10 plus 22. That will give us 32. So to proceed, we divide by the coefficient of x, which is 8, so that we solve and find the value of x. So we divide both sides by 8. And when we divide both sides by 8, our value of x will be 4. So when we do that, it means we have solved the simultaneous equations by the elimination method. You can check by substituting the value of x, which is 4, and the value of y, which is negative 1, into any of the two equations, either equation 1 or equation 2, to confirm that the two values that we have found are indeed correct. For example, 3x simply means 3 times 4, which is 12. Then 2y simply means 2 times negative 1, which is negative 2. That should give us 10. We are saying 3x is 12, which means 12 minus 2 is 10. And that can be the same if we were to check with equation 2.